All right, and hello everybody. So I am back once again with the latest case in this year's Road to Las Vegas series called Bit of Music. Now, before I get started, just a quick note here that I am currently on vacation. I am not at home, so my recording setup is going to be different. I don't have all my mics and everything like that, but we'll see what we can do. We'll try to get through it. This case was a really fun one. It's related to MIDI and how music was composed on the computer probably back before you got a lot of the MP3 files and things like that. But let me just read the introduction to this case for you. You are setting up your whole DJ setup for your next big stage. In digital music, instruments communicate via the MIDI standard interface. Communication happens with bytes exchanged from a controller to each instrument. The instrument has to identify if the message is addressed to it, and if so, what kind of action it should trigger. A message can contain up to 3 kinds of bytes: status byte, data byte 1, data byte 2. Each byte is a binary 8-digit sequence, 24 binary digits in total. Now, I'm not going to read through the rest of it. There's a lot of details about how these bytes work. If you want to read it, you can pause the video now. You can read at least the first couple of bytes, or check in the description of the video for the introduction to this case, where it will talk about the 3 data bytes in more detail. But before I go on, what I just want to show you here is over here, we have a table with the instrument, the channel that it plays from, and a note if it requires a certain note to play. And on this note page, we have, let me zoom in here a little bit, we have a list of notes and the key that is used to play those notes. So, without further ado, I am going to go ahead and give this case a try. Let's see if I can get full marks within 30 minutes. Here we go. Now in level 1, we are asked to find which channel the status byte message is addressed to. And we are told that we can find this by converting the last 4 binary digits into a decimal. So I'm going to first pull out those last 4 digits by using the write function, and then use Excel's bin to dec to convert that binary number into a decimal number. Now in level 2, we are given the complete note on message, and we are asked which instrument is this message addressed. And we are told that we can find the instrument by looking up digits 5 through 8 on the instrument channel. Now in this level, we don't have percussion yet. That's going to be in the next level, and that's going to be a little bit more difficult. But I'm going to use the same bin to dec formula, taking the digits 5, 6, 7, and 8 using the mid function and looking that up in the instrument table here at the top of the sheet. Now in level 3, we are adding the percussion instruments. Now the tricky part with the percussion instruments is they are all on the same channel. They're on channel 10. So in order to differentiate between the percussion instruments, we have to figure out what note that this message is calling, and that will tell us what instrument that we are going to have. So I'm going to create 2 columns here. First, to bring out the instrument channel. So you see in example 3 that instrument channel is 10, meaning that's percussion. And then I'm going to bring out the note, and I'm going to bring this out for all of the instruments. I know that for non-percussion instruments, this doesn't matter, but this will help lay out the data so that if I run into any troubles, I can very easily go back and fix them. Now, when I'm trying to highlight the whole columns, you'll see here that it highlights B and C. That's because that notes header is merged. I'm going to unmerge that so I can highlight the columns more easily. So now I have instrument channel and note for each message, and I'm going to use those to look up the instrument. If it's percussion, I'm going to use the note to look up the percussion instrument. If it is not percussion, I'm just going to use the channel to look up the normal instrument there. Now for level 4, we are given a bunch of messages together, and the messages are separated by a semicolon. What we need to do here is we're asked what is the average velocity across the note on messages. First thing you see I did here is I looked at the length of all the messages to see if I'm dealing with variable lengths. Fortunately, in this case, we are not. But if we were, then we would have to make sure that we use dynamic arrays properly, or make sure that our model covers the largest possible case. So here I am going to use a data table. So I brought in the information based on the case number. I am going to use this text split function to split the messages based on the semicolon. So I have them here. And then now I have the sequence column, which allows me to basically number all of the rows there. Now what I'm going to do, I know I don't have to do all this, but this will help me in the later levels, is I'm going to pull out all of the necessary information from that message. So I'm going back to the instructions and I'm looking at the 3 bytes that I need. I need the status byte, data byte 1, and data byte 2. And those are basically the 8 digits in each message. Now from the status byte, we also have the message type, which is the first 4 digits. You see, I actually pulled that out instead of the status byte itself. The instrument is the next 4 digits, and then data bytes 1 and 2 are going to be the 8 digits following that. Now I'm going to take all of these messages and look them up in their respective tables so that instead of dealing with 1s and 0s, I'm going to be dealing with text that I understand. So I'm going to start with the message type. Now, there are 3 possible messages. I'm going to copy and paste them all over here to the sheet. Well, I'm going to retype them really. And then I'm going to use a switch function to pull out the appropriate message based on the message type found in this column. Now I'm going to bring out the instrument just like we saw in the earlier level. I'm also going to bring out the note. Now remember, if it's percussion, then the note actually determines what instrument it is. So I'm actually going to look up the note first before I go back and look up the instrument. Now finally, this velocity is going to be based off of data type 2, and that's going to be a very simple converting that binary number into a decimal number. Now for this level, it's the velocity that we have to find the average of, but we only need to find the average if the message is note on. So I'm going to use my average ifs function. So if the message says note on, find the average of the velocity. We need to round that to the nearest full digit, so I'm just going to simply round to 0 decimal places, and that should give me all of the answers for this level 4. Now on to level 5. They have changed the messages from binary messages to hexadecimal messages. Interestingly, that's not something they mentioned in the introduction video. Now I'm going to start here by checking are all of the messages the same length. They are. And because the only real change is converting from binary to hex, I'm going to try to use my stain model and just tweak it up a little bit to change all of the messages into binary, to be able to use that binary code to find the answers here. Now you see what I'm trying to do is I'm trying to convert the whole dynamic array into a binary number. That's not working out for me. So I am going to go back and try to do it row by row instead. The reason why the first bit message wasn't working was because I was trying to restrict Excel to 4 digits, but that first bit is actually 8 digits long, so I've not given enough space to fill out the full binary number. Now the question for this level asks which note is being played the most. So I'm going to use a group by function to find out which note has shown up the most often. I see for the example that is C2, which when I look back at the case file that does match. So now I'm going to do the data table for the whole level. Now we go on to level 6. One of our cables seems to have issues. We are no longer given the semicolon function, but we still know that each message is 6 character length. And the question that we are asked is which instrument is not addressed in this level. So what I'm going to do here is I am going to add an extra column to tell me where each message should start. The first message should start at the first character, and every following message should be 6 characters away from that. Now there could have been a mathematical function I could have used on the sequence column, but solving this here for this video, I couldn't think of it off the top of my head, so I thought, let's just do this the easy way. So now that I have where each message should start, I can use the mid function to pull out every group of 6 characters starting at that position. Now that I've done that and deleted my continuously calculating data table, now I have all of the information from these messages, and I should be able to pull out how many times each of these instruments were called. So I'm going to create another table here on the far end, basically listing each instrument and listing how often it comes up in these messages. One of these instruments should be 0, so I can use an XLOOKUP function to look up that 0 and return the corresponding instrument. Here for the example, I get the acoustic grand piano, which looking in the example on the sheet is correct. So I'm going to bring in once again all of my question numbers and run through the data table. Now we get on to level 7, and this time we need to consider when notes are triggered on and when they are triggered off. And this level asks us which note is triggered on and then off first. We need to not only consider the note, but we also have to consider the instrument that the note is being played on. So what I want to do is I want to bring these full instructions over again. I haven't done so for the past few levels because those were simpler, but these ones I feel have a lot of information in them. So I'm going to copy the full instructions over, and then I'm going to use that to complete this model once again. So you see here I have all the messages. I'm going to use this XLOOKUP to link to the main sheet there. I'm once again going to check the length of all these, see if they match. They do match. These are 300 characters in length. The last level was only 240, so that means we have a few more messages. Now because I didn't use dynamic arrays for the start of the message, that means that I need to adjust some of these formulas to account for the longer message length. Now that I do that and I see all my following dynamic ranges do count accordingly, now I can continue with this model. So there's, once again, 3 things we need to consider. We need to consider what instrument is being played, we need to consider what note is being played by that instrument, and we need to consider the message, when it turns on and when it turns off. At first I set this table in this order, but I noticed these 3 columns are right next to each other, and so I thought to do a filter it might just be easier just to highlight all 3 of these columns at the same time. And I'm going to filter for whichever one says note on. So here we get a list of all of the notes that have turned on at some point in this message. And now I'm going to look for the position when that turns on. So what I'm going to do is I'm going to do this concatenated XLOOKUP function. That allows me to look up multiple columns at the same time, and then to return the sequence number. So that tells me at what point did that note turn on. I'm going to do the same thing to find out what point that note turned off, but what the difference is instead of looking for note on, I'm going to look for the note off message. So that part I'm going to have to type in manually. So here we see that the acoustic grand piano plays A#4, turns on sequence 39, turns off on sequence 41. That is correct, and I am going to use that to start building my data table here. I'm going to look for the first off sequence and look up the appropriate according instrument. Now when I run through this and put the answers in, some of my answers are off. Number 121, I get the answer piccolo, but that answer is coming back wrong. So here what I'm going to do is I'm going to look through my table and try to figure out why this is wrong. I see the piccolo turns off on sequence 19, whereas the drawbar organ turns off on sequence 32. So that seems to be okay. But upon further instruction, I noticed that the piccolo turns off before it actually turns on. And so that actually does not count for this level. I need to see when it turns off after it turns on. So I'm going to have to create another calculated column to not consider those that are turning off before they actually turn on. Now I'm going to look for the maximum in this count column, but it's not going to work so well because I'm bringing up a bunch of NA errors. The reason I'm bringing up those NA errors is because I wanted this table to be longer to account for more possible options. So what I really need to do is I need an if error statement in this count C column. Basically, if something comes up as an error, just leave it blank so that it's not considered in the data table. Now I get the appropriate answers, I paste those over, those all link up properly, and now we can move on to the bonuses. Bonus 1 asks how many ones are in all of the level 1 messages. So what I'm going to do is I'm just going to simply concat all of these messages together, and I can use this len and substitute combination, which will tell me how many ones am I taking out if I substitute a 1 for nothing. Bonus B, which letter appears exactly 22 times in the level 2 answers? So what I want to do here is I want to count all of the letters for all of the answers here. So I'm going to bring out my alphabet using this car sequence combination, and then I'm going to use that same len substitute combination that we talked about just a moment ago to find out how often each letter appears. Now what you may also notice is I'm using an upper function. I don't know if this is actually required, but in order to get a proper count, I want to turn all of my letters into uppercase letters, so that way an uppercase or lowercase version of that letter is treated the same. So now I get the count of all the letters in each of the answers. What I'm going to do is I'm going to create a row at the bottom here, which adds up all of those numbers for each letter. And then I'm going to XLOOKUP 22 because the question is which letter appears exactly 22 times. Bonus C, in the level 3 messages, we want to count the number of zeros, subtract the number of ones, divide that result by 2, we get a number, and we are asked how often, and we are asked which letter appears that number of times in the level 3 answers. So very similar to level 2, except we have to find out the actual count that we are looking for. So what I'm going to do first is I'm going to count the numbers of zeros and ones, use that to find out what is the number that I'm looking for, and then I'm going to use the same strategy that I used in the previous bonus to find out which letter appears that number of times. So I see there are 260 zeros, 220 ones. Subtract those two, we get a number of 40. Divide that number by 2. We are looking for which letter appears 20 times. And here we get that the letter R appears 20 times. Bonus D, what is the sum of all the velocity values in level 3? So we're going back to level 3, and I don't recall us calculating the velocity levels. But I do remember that the velocity is calculated simply as the last 8 digits, converting them to a binary number. So I'm going to take the right 8 digits out of all of these messages, using the bin2 deck to convert them to decimal, add those up together, and I'm going to simply take that answer and bring it up. Now you notice that bonus 3 has now marked incorrect. That's because I added the column and that shifted some of the answers over. So I'm just going to manually type in R. Bonus E. In the level 7 example message, after converting all the hexadecimal values to binary numbers, treating those binary numbers as decimal values, what is the sum of all of the status byte messages in this level? Now, because I have this nice detailed model, I can very quickly find all of those status messages. I copied the formula, tried to paste it over. That's not going to work so well. So what I really need to do is I need to go back and just simply copy that number. Now, when we do the decimal figure, let's bring them all out as text. We need to multiply 1 to bring them back as numbers. Adding them all up together did not give me the correct message, but that's because I'm still working on game 121 instead of example 7. When I change this to example 7, I copy that number, bring that over to the sheet, and that will give me the correct answer and the full solve for this case. All right, and there we go. A couple of small slip-ups, but I was able to solve it just under 26 minutes. On the live solve, it was these two bonuses that I got wrong. Sad, because everything else I got perfectly right until I just hit those last two. And then I, for whatever reason, I don't know why, I included the example in this one. And this one, I misunderstood what they meant by treat each binary status byte as a decimal number. I converted them all to decimal numbers, which did not give me the answer that they were looking for. But otherwise, this was a really fun case. Thank you, Julien and the FMWC team, for putting this out. I'm happy because this case, I finally qualified for the World Championships, the main event happening this October. So I'm really looking forward to that. Thanks for taking the time to watch this video. If you enjoy this content, please give me a like and subscribe. And I look forward to seeing you in the next video, whenever that comes out.